This is lecture 5, and in this lecture I am going to discuss about a very important law in electrostatics, that is Coulomb's law in electrostatics. Coulomb's law in electrostatics is used to find the electric force between point charges. In the last lecture I explained what is meant by point charges, and in that lecture I told you that when two like charges are placed near to each other, there will be repulsive force between the charges, and when two unlike charges are placed near to each other, there will be attractive force between the charges. Now we want to find the amount of attractive or repulsive force. We already said that there will be attractive or repulsive force. Now we want to find what is that force, how much it is. So in order to find the amount of force, you can use a law, and that law is called a Coulomb's law in electrostatics. It is used to find electric force between point charges. Consider the diagram. There are 2 point charges. One is Q1 and other is Q2. Here you can see Q1 is a point charge, Q2 is another point charge, and they are separated by a distance r. So in between Q1 and Q2 there is a difference of r. This r is not that much enough, it is small enough. Okay, now you want to find the electric force between Q1 and Q2. Sometimes it will be attractive and sometimes it will be repulsive, depends upon the charges Q1 and Q2. If Q1 and Q2 both are same type of charges, then the force between them will be repulsive, and if Q1 and Q2 are opposite type of charges, then the force will be attractive. So whether it is attractive or repulsive, you can find out by checking whether the charges are similar type or opposite type. In this Coulomb's law, we want to find what is that amount of force, how much force is there. So in order to find that, we can use this Coulomb's law in electrostatics. So I will give you the statement of Coulomb's law first. According to Coulomb's law, the force between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of their distance. So if you check it here, you can see in this law Coulomb is actually expressing the force between 2 point charges in terms of charges and distance between the charges. You can see here, if the electrostatic force is represented as F, then according to Coulomb's law, the electrostatic force between the point charges is directly proportional to the product of the charges. There are 2 charges, Q1 and Q2. So it is directly proportional to Q1 and Q2, and they are saying product of charges. So F is proportional to Q1 into Q2. Also, it is inversely proportional to the square of their distance. So inversely means 1 by distance, but it is not distance, it is square of the distance. That means F is proportional to 1 by r square. So according to Coulomb's law, the force between 2 point charges is directly proportional to the product of their charges Q1 and Q2 and inversely proportional to the square of the distance between them. Now if you combine both, then you can write it as F is proportional to Q1 Q2 divided by r square. So there is a proportionality sign. Now how to remove that proportionality sign? And you need to change it into equal to sign. So what you will do? Multiply with a constant k. So what you will get? After multiplying with a constant k, this proportionality sign will be removed and you will get F is equal to k into Q1 Q2 divided by r square. So this is the mathematical statement of Coulomb's law. Here the proportionality constant K is not equal to 1, but it is given by K is equal to 1 by 4 pi epsilon. This symbol is called epsilon, and epsilon is called permittivity. The value of epsilon will change, depends upon the medium in which you are keeping these charges. If you are keeping it in water, then this total K value will have some value. If you keep it in kerosene, this K value will be different. If you keep it in air, this K value will be different, because this epsilon will change, depends upon the medium in which you are keeping these two charges. So this is the final expression for Coulomb's law in electrostatics. Electrostatic force F is equal to 1 by 4 pi epsilon, because K is equal to 1 by 4 pi epsilon. So F is equal to 1 by 4 pi epsilon Q1 Q2 divided by R square. This is the general expression for Coulomb's law, which is used to find the force between two point charges which are placed some distance away. Now from this expression you can make some generalizations. First one, if Q1 and Q2 they are point charges, if the charges are having values which are these Q1 and Q2 are having some high values, then you can see Q1 and Q2 they are in numerator and you are multiplying Q1 and Q2. So if the charge is big enough, if it is having some amount of charge which is having some values, then force will also increase. That means when charge increases, any of the charge increases or both the charge increases, force will also increase. And if the separation between the charges increases, if you move this Q1 away from Q2, then what happens? R will increase. When R increases, R is in denominator. So when R increases, force will decrease. That means if the charges are far away, then R will be more, so that F will be less. That means when charges are placed far away, they will exert only less force between them. So if they are like charges and if they moved away, that means since they are like charges, there will be repulsive force. But since you are moving it away, and hence R will increase, so that the repulsive force will be less as compared with the repulsive force in this case. If you move Q1 again and again far away, then R will again and again increase, and hence repulsive force will decrease. So this is about Coulomb's law. Now in the case of air or vacuum, I will rewrite Coulomb's law. So before going on to that, I want to repeat it again. According to Coulomb's law, the force between two point charges is directly proportional to the product of the charges and inversely proportional to the square of their distance. So F is proportional to Q1 Q2 and it is inversely proportional to 1 by R square. So if you change this proportionality, then you need to multiply with a constant K in order to write it as equal to, and that K is given by 1 by 4 pi epsilon, where epsilon is called permittivity. This permittivity is different for different medium. When you keep this Q1 and Q2 in water, permittivity will have some value. When you keep it in kerosene, permittivity will have some different value. When you keep it in air, permittivity will have some other value. So K will change depends upon the medium, and hence force will also change depends upon the medium in which you are keeping these two charges. Now I am going to represent Coulomb's law between 2 point charges when you keep both the charges in air. When it is in air, let us write the Coulomb's law. So for writing Coulomb's law in the case of two charges which are placed in air, in general Coulomb's law is given by F is equal to 1 by 4 pi epsilon q1 q2 by r square. Here you can see epsilon. Epsilon is actually equal to epsilon 0 multiplied by epsilon r, where epsilon 0 is the permittivity of free space, and epsilon r is called relative permittivity, or we will use another term that I will discuss later, that is called a dielectric constant. So this is the expression for epsilon. Epsilon is equal to epsilon 0 into epsilon r. Now in the case of air, if you place the two charges in air, then for air this epsilon r is equal to 1. This epsilon r will change depends upon the medium, whereas this epsilon 0 is a constant for all the medium. So depends upon the medium, this epsilon r will change. So when epsilon r changes, this total epsilon will change. That is why depends upon the medium, this epsilon is changing, because in all the medium epsilon r is different, but epsilon 0 is a constant in all the medium, and the value of epsilon 0 is given by 8.854 into 10 raised to minus 12 farads per meter. This is the value of epsilon 0. It is a constant for any medium, but epsilon r is not a constant. Depends upon the medium, value of epsilon r will change. So when epsilon r changes, even though epsilon 0 is a constant, its product will be different. That is why epsilon is different for different medium, and epsilon is called permittivity. That is equal to permittivity of free space multiplied by relative permittivity. This epsilon r is also called as dielectric constant, that I will discuss in the coming classes. Okay, now our aim is to find Coulomb's law for point charges when they are placed in air. So this is the general equation, 1 by 4 pi epsilon q1 q2 by r square, where epsilon is equal to epsilon 0 into epsilon r. So in the case of air, this epsilon r value is 1. Here you can see the table of values of epsilon r for different materials. For free space it is sharp 1. For air it is almost 1. 1.0006 means it is 1. You can take it as 1. Rubber it is 2 to 3.5. Like that, paper, mica, etc. it is given. So our aim is to find the value of epsilon r for air or free space. Both you can take it as 1. Okay, so that Coulomb's law in air or free space. Here you can also consider that free space, that is vacuum. In both the cases Coulomb's law will have same form, and what will be that form? In both the cases, air or free space, epsilon r is 1. So that Coulomb's law will be 1 by 4 pi epsilon is equal to epsilon 0 into epsilon r, where epsilon r is equal to 1. So epsilon will changes to epsilon 0 q1 q2 by r square. This is the form of Coulomb's law in the case of free space, that is vacuum. or air. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. In general, F is equal to 1 by 4 pi epsilon q1 q2 by r square, but epsilon is equal to epsilon 0 into epsilon r, and in the case of air, epsilon r value is 1. In the case of free space also, epsilon r is equal to 1. So 1 into epsilon 0 is epsilon 0, and hence this epsilon can be replaced with epsilon 0. This is the equation for electrostatic force when charges are placed in air or free space. Only when they are placed in air or free space you can use this expression. Instead of epsilon you can use epsilon 0. Okay, and this epsilon 0 value I already gave, 8.85 into 10 raised to minus 12, and 1 by 4 pi is a constant. So if you multiply all these things, epsilon is a constant, 1 by 4 pi is also a constant, you will get another constant. So if you multiply 1 by 4 pi and the value of epsilon 0, you will get another constant, and that value is 9 into 10 raised to 9 Newton meter square divided by Coulomb square. You can verify the unit by dimension analysis. You will get Newton meter square divided by Coulomb square. Here you can see a new unit, that is Coulomb. C, capital C. Capital C is called Coulomb. Coulomb is the unit of charge. SI unit of charge is Coulomb. That is why you are getting Coulomb square here. So remember that SI unit of charge is Coulomb. So we discussed about Coulomb's law in air or vacuum. Now if you are placing two charges, Q1 and Q2, and they are at a distance of r, not in air or vacuum but in some other medium. It is not air or vacuum, your charges are placed at some other medium and they are separated by a distance of r. Now what will be Coulomb's law? So write the general equation, 1 by 4 pi epsilon q1 q2 by r square. This is the general Coulomb's law. Here you can rewrite it as 1 by 4 pi, epsilon is equal to epsilon 0 into epsilon r, then q1 q2 by r square. Now if you check this expression, you can see that 1 by 4 pi epsilon 0 q1 q2 by r square, this is the expression for Coulomb's law in air. 1 by 4 pi epsilon 0 q1 q2 by r square. This is the expression for force in air. After that only one term is remaining, that is epsilon r. So if you eliminate epsilon r, rest of the terms are nothing but Coulomb's law in air or vacuum, which will give you the force of point charges in air or vacuum. Okay, so this you can rewrite as equal to F air. F air means the electrostatic force in air divided by only one term is remaining, that is epsilon r. Okay, so Coulomb's law in some other medium can be expressed as F air by epsilon r, where F air is the force in air between two charged particles, and epsilon r is the dielectric constant or relative permittivity in the medium. So let us consider an example. You are having two charges, q1 and q2, separated by a distance of r, and it is in air, and at the same time you are having another two charges or same two charges, and they are separated by the same distance, but now you are placing it in water. Now you want to find what is the amount of electrostatic force between the two charges when they are placed in water. So how to find it? So for that you can find out epsilon r for water, that will be available. Now if you find the force between the two charges in air, that is F air, and then divide with the relative permittivity of water epsilon r, then you will get the amount of force in water. So F water is equal to F air divided by epsilon r. And also if you check the table, you can see that air or free space, they are having the minimum value of epsilon r. All the other mediums are having an epsilon r more than 1. So for other mediums epsilon r is always more than 1. Here it is water. So for water also this epsilon r will be more than 1. That means you will get some force in air, then you are dividing with the epsilon r. When it is placed in water means epsilon r of water you will divide, then you will get force in water. So force in air divided by epsilon r, where epsilon r will be more than 1 because it is water. Epsilon r of water will be more than epsilon r of air. That means a number divided by a number more than 1, so that this value will be less than this value. So the force between two charged particles when they are placed in air will be greater than the force between the same two charged particles at the same distance when they are placed in water. That is clear from this equation. So when two charged particles are separated by a distance, there will be maximum force when they are placed in air, and when you are placing the same two charges in some other medium, then the force on the two charged particles will decrease, depends upon the value of epsilon r. If the medium is having maximum epsilon r, then force in that medium will be minimum compared with force in air. So this is about Coulomb's law. Now in the next lecture I will discuss Coulomb's law in vector form and then solving numericals. So now onwards the classes will become more mathematical and numericals will come.